Here we are back in topic 9.2 part B. This time we're going to solve these inequalities, but now we're going to look at solving them algebraically. Now the first one, example 1, revisiting it, we found that the roots were at -1 and at +3. We found that by factoring. So now instead of trying to find the intervals over where it is by graphing, we're going to draw them on a number line. So here are the roots. One's at -1, one's at +3, and now we're going to take some test points and we're going to figure out where the graph is positive and where it's negative. In other words, where the graph is going to go below the x-axis, where it's going to go above the x-axis. So here is the interval where x has to be less than -1. Here, of course, is the interval where x is greater than 3. And then in between here is where x is going to be between -1 and +3. So if we pick the test point, my favorite test point is 0. Let's plug in a 0. But first of all, we're saying that -1 and 3 are part of our solution because it's less than or equal to 0. So those two are automatically going to be circled in as part of our solution. Now, pick a test point to see if the section of graph, or interval as we call it, is going to be positive or if it's going to be negative. So here I pick 0. That's why there's a little red circle and 0 on the number line. If you substitute 0 in there, you're going to get -3 is less than or equal to 0. So yes, that's going to be part of our solution. That section between -1 and 3 is also part of our solution. If you pick a number on the other side, let's say 5, and plug it in our equation, 5 squared minus 2 times 5 minus 3, well, that's going to give me 12. It's less than or equal to 0, so no, that's not part of our solution. Let's try -3 on the other side. Well, I also get 12 is less than or equal to 0, so no, that's not part of our solution. So instead of graphing, we found the roots by factoring x squared minus 2x minus 3. And then from the roots, we drew a number line. And on the number line, we determined where our graph was going to be positive, where it was going to be negative, and there we can say is going to be less than or equal to 0. So our solution set is going to be the set of all x, such that x is going to be less than or equal to 3, but greater than or equal to -1, and it's going to be any real number over that interval. This method is called the roots and test method, roots and test points. And using the roots and test points is going to be the only way that we're going to be solving these algebraically. Example 2. Solve a quadratic inequality of the form ax squared plus bx plus c is less than 0, where a is negative, less than 0. So when we're asked to solve this, we know that the roots were at -3 and at +4. Without graphing our solution, we're going to draw our number line, and we're going to put our roots on there, -3 and +4. Now, because it says it's only going to be less than 0, we're just going to draw open circles around 3 and 4 because they're not part of our solution. Now, again, we're going to write our intervals down. This is where x is going to be less than 4 and where it's going to be greater than -3. Over here is where x is going to be obviously less than -3, and over on the other side is where x is going to be greater than 4. So let's try our test point again. Again, my favorite one is 0. It always works so nicely in an equation. So -x squared plus x plus 12 is less than 0. 0 plus 0 plus 12 is less than 0? Nope. So that's not part of our solution. Let's take 5. And we got negative of 5 squared is -25 plus 17 is less than 0. Yes, that works. So that's part of our solution. And on the other side, -x squared plus x plus 12 is less than 0. Let's try -5. And over here, you're going to end up with -18 is less than 0. Yes. So again, we've got a two-part solution. we're going to say that the solution set is the set of all x such that x is less than negative 3, or x can be greater than 4, and x is going to be any real number over that interval. Here in example 3 again, to solve this one, which we already did, we know that the roots were going to be at approximately 4.8 and negative 1.3. So describe the solution of our inequality. Well, let's draw our number line. We're going to put down our 4.8 and our negative 1.3. That should be negative. There it is. That interval is going to be, x is going to be less than 4.8, but greater than negative 1.3. Over on this side, we're going to have x is greater than 4.8, and on the other side is where x is going to be less than 1.3. So now we're going to plug in a value. Always start with 0. It's nice and easy to work with. Test point is 0. 2 times 0 squared minus 7 times 0 is greater than 12. Is 0 greater than 12? Of course not. No, that's not part of our solution. Over here, 5. 2 times 5 squared minus 7 times 5 is greater than 12. Is 15 greater than 12? Yes. And this time over here, I'm going to pick something like negative 2. Plug that in and check, and you get 22 is greater than 12. So yes, that's also part of our solution. So to graph this, you would draw open circles around 4.8 and negative 1.3, and that's going to be greater than, that's going to be where it's less than, and we can also put that down as our solution set, all x, such that x is less than negative 1.3, or x is greater than 4.8, and x is any real number. For your assignment, to do page 45, numbers 4 to 9 using the roots and test points method, and for 4, 5, and 6, wait a sec, using the roots and test point method for 4, 5, and 6, I want you to use the graphing method for number 7, and then you can use any method that you want for questions 8 and 9.